गुड मॉर्निंग बच्चों। आई होप आप सब अच्छे होंगे और अपने घरों में सेफ़ होंगे। आज हम चैप्टर यूनिट्स एंड मेज़रमेंट का फर्स्ट लेक्चर डिस्कस करेंगे और इसमें जो जो टॉपिक्स डिस्कस करने हैं वो देख लेते हैं पहले। द वेरी फर्स्ट टॉपिक इज़ फिज़िकल क्वांटिटी, फंडामेंटल एंड डिराइव्ड क्वांटिटीज़, यूनिट्स, फंडामेंटल एंड डिराइव्ड यूनिट्स. The third topic is characteristics of a standard unit. Then system of units including FPS, CGS, MKS and SI system of units. Then some definitions of fundamental SI units. So let us start with the very first term, physical quantity. What is a physical quantity? Anything which can be measured is known as a physical quantity. A quantity which is measurable is called physical quantity. And the fundamental quantity, before explaining about the fundamental quantity, I want to give some points about physical quantity. If we measure anything, definitely that measurement have two things. One is called its magnitude and other is its unit. Then if we derive or if we write an equation, then the equation may be like this: P equals to N and U. P stands for physical quantity, N stands for its magnitude and U stands for unit. Any physical quantity have these two things, numerical value as well as unit. That numerical value is called the magnitude. Now, what is a fundamental quantity? A physical quantity which is the base and cannot be derived from any other quantity is called fundamental quantity. The basic quantity, and the basic quantity definitely it cannot be it cannot depend on any other quantity, therefore it cannot be derived from any other quantity. This is basic one, and definitely these quantities are not interrelated to each other. And some examples are there: length, mass and time. What is important in these examples? You can't relate length and mass, you can't relate mass and time, you can't relate mass and length. That means there is no any interrelation between these quantities. They are complete by their own and the basic one, therefore they are known as fundamental or basic physical quantities. Then derived quantities, surely these quantities can be obtained by using fundamental quantities, and definitely they depends upon fundamental quantities. A physical quantity which can be derived or expressed from base or fundamental quantity or quantities is called derived quantity. These are some examples of derived quantities. I will include area, volume and speed, velocity, acceleration, force, momentum, torque, energy, pressure. Among these quantities, some of the quantities you all are known about them. In junior classes, you must study about speed, velocity, acceleration, force, momentum, energy, pressure, then density. We have some idea of resistance also, magnetic moment, not magnetic moment, but we have an idea of magnetic field. And so many quantities are there which are derived quantities. Now, what is a unit? Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. There are some terms. Certain basic means there is some basic measurement, and arbitrarily chosen जो डिसाइड किया जाए खुद से, और खुद से का मतलब यह है कि हम सब अलग अलग अपनी अपनी यूनिट्स नहीं डिसाइड कर सकते हैं, क्योंकि अगर हम यूनिट्स डिसाइड करने के लिए अपने अपने स्टैंडर्ड्स लेंगे तो सभी के जो है मेजरमेंट्स अलग अलग होंगे। तो इसके लिए जो है अथॉरिटीज़ हैं इसके लिए इंस्टीट्यूट्स हैं जो डिसाइड करते हैं कि यूनिट का मेज़रमेंट कैसा होना चाहिए और उसको चूज़ करने का तरीका क्या है। इंटरनेशनली एक्सेप्टेड, जैसा मैंने कहा कि इंटरनेशनली एक्सेप्टेड होगी और ये कोई स्टैंडर्ड होगी जो कि रेफरेंस के तौर पे लिया जाएगा। जैसे मैं एग्जांपल दूं आपको, इफ़ यू आर मेजरिंग लेंथ ऑफ एनी टेबल, उसके सरफेस एरिया का टॉप का अगर आप लेंथ फाइंड आउट करना चाह रहे हैं तो डेफिनेटली इट मे हैव सम मेजरमेंट, मे बी 1 मीटर और 1.2 मीटर और 1.5 मीटर. So what is 1 meter? 1 is the number, meter is the unit, and if the measurement is 1 meter, it is 1 times of the standard value. If it is 1.5 meter, it is 1.5 times of the standard value. If it is 10 meter, if any length comes out to be 10 meters, that means it is 10 times of the standard value, and that standard value is called unit. Then fundamental units, these are the units of fundamental physical quantity. The units of the fundamental or base quantities are called fundamental or base quantities. Some examples: meter, kilogram, second, and there are some others also. These units are generally used in mechanics, the branch of physics. Then derived units, the units of the derived quantities which can be expressed from the base or fundamental quantities are called derived units. And as these are the units of derived quantities, definitely examples are meter per second, kilogram per meter cube, kilogram meter per second square. There are certain quantities and these units belongs to those quantities. Then system of units, a complete set of both fundamental and derived unit is known as the system of units. Fundamental and derived units, सभी units को मिला के जो एक setup system बनेगा, that is known as system of units. Characteristics of a standard unit. क्या कैरेक्टरिस्टिक्स हो सकते हैं कि स्टैंडर्ड यूनिट के? कैरेक्टरिस्टिक्स से मतलब उसके प्रॉपर्टीज़ का भी टर्म्स ले सकते हैं आप, और स्पेसिफिक चीज़ें हैं जो एक यूनिट में होनी चाहिए, उन्हीं को आप कहते हैं कैरेक्टरिस्टिक्स ऑफ स्टैंडर्ड यूनिट्स. A unit selected for measuring a physical quantity must fulfill the following requirements. What are those requirements? It should be well defined. इसकी डेफिनेशन बिल्कुल क्लियर कट होनी चाहिए और किसी भी तरीके का उसमें जो है कन्फ्यूजन या किसी तरीके की कॉम्प्लेक्सिटी नहीं होनी चाहिए. सिंपल हो बट इट शुड बी वेल डिफाइंड. इट शुड बी ऑफ सुटेबल साइज़. जो भी स्टैंडर्ड रेफरेंस हम लेते हैं उसका साइज़ सुटेबल हो. ये बहुत बड़ी भी नहीं होनी चाहिए और बहुत छोटी भी नहीं होनी चाहिए. देन इट शुड बी रिप्रोड्यूसिबल एट ऑल प्लेसेस. अगर आपको इस यूनिट को या स्टैंडर्ड वैल्यू को, रेफरेंस वैल्यू को दोबारा से जो है बताना है कि ये कितनी होगी, कैसे निकाली जाएगी, तो इसमें ये कैरेक्टरिस्टिक होना चाहिए कि इट शुड बी रिप्रोड्यूसिबल. देन इट शुड नॉट चेंज फ्रॉम प्लेस टू प्लेस और टाइम टू टाइम. प्लेस चेंज होने पे चेंज नहीं होनी चाहिए और टाइम के साथ इसमें कोई चेंजेस नहीं आने चाहिए. It should not change with physical conditions such as temperature, pressure, etc. Then it should be easily accessible. और अगर इसके एक्सेस की बात करें तो it should be easily accessible. Then the various system of units. What are the various systems of units? Here are the: in earlier time, various systems like FPS, CGS and MKS systems of units were used for measurement. They were named so from the fundamental units in their respective system as given below. What are these systems, FPS, CGS and MKS? Here is the quantity. The quantities are length, mass and time. The dimensions are there. We will discuss later in this chapter only what are the dimensions. So then the system of units: in FPS, length is measured in foot, mass is measured in pound and time is measured in second. Similarly, in CGS system, length centimeter, mass gram, and time second. In MKS, length is measured in meter, mass is in kilogram, and time is in second. Now, what is the SI system of units? सिस्टम इंटरनेशनल डी यूनिट्स, ये फ्रेंच में है, इसको शॉर्ट फॉर्म में हम लोग SI सिस्टम ऑफ यूनिट्स कहते हैं. तो SI यूनिट्स, द SI system with a standard scheme of symbols, units and abbreviations was developed and recommended by General Conference on Weights and Measures in 1971 for international uses in scientific, technical, industrial and commercial work. Then this is the system of units which is at present accepted internationally. The SI system uses decimal system and therefore conversion within the system are quite simple and convenient. Decimal system means for higher units you can multiply the smaller units with multipliers of tens by multiplying 10, 100, 1000, 10,000. In this way you can get the bigger units, and by dividing the bigger values by 10, 100, 1000 and so on, you will get the smaller values. This is exactly the decimal system. Now the fundamental units in SI system. In SI system there are 7 quantities. Among them 7 are the fundamental physical quantities and 2 are the supplementary quantities. The 7 quantities, they are from different branches of physics such as length, mass and time. Generally these units are used in mechanics, and if we think about electricity and magnetism or electromagnetism, electric current is involved, and if we think about thermodynamics, there is a quantity temperature, and when we talk about the measurement of light, it is light intensity, and if it is the amount of substance, and generally it is used in chemistry, amount of substance, this one, and the length, SI unit of length is meter, the symbol is small m, mass kilogram, time second, electric current ampere, thermodynamic temperature, or simple you can call temperature also, Kelvin, light intensity, then amount of substance, and the supplementary units are plane angle and solid angle. The plane angle is formed in a two-dimensional setup, and solid angle, it is a concept of it is generally arises in three-dimensional approach. Plane angle is angle formed by any arc at the center, and solid angle, it is angle formed by an area at any point. We will discuss separately about these quantities, and there are basic definitions also. Definitions of SI units. These are, the very first one is meter. The meter is the length of the path travelled by light in vacuum during a time interval of 1 upon this much. That value, it is speed of light, 299,792,458 of a second. 1 upon that value, this 299 and something is speed of light. In short form or in approximate value, it is 3 into 10 raised to power 8 meter per second is speed of light. Then the meter is what? Length of path travelled by light in 1 upon speed of light of a second. And kilogram, the blue colored one is the old definition. The kilogram is equal to the mass of an international prototype of the kilogram, a platinum iridium alloy cylinder kept at International Bureau of Weights and Measures at Sèvres near Paris, France, and this definition is of 1889. But in 2019 this definition is changed because there is some deterioration of platinum iridium alloy in the passage of time. Therefore it is generally it was thought that this definition should be rectified, and as in case of meter, it is defined in terms of speed of light, which is not going to change with passage of time, and it has no effect on physical conditions. So kilogram is defined in terms of a constant, and that constant is Planck's constant. And the value of Planck's constant is measured very accurately, and if we define mass in terms of Planck's constant, definitely we have some accurate value of kilogram. And second, the second is the duration of this value 9192631,770 periods of the radiation corresponding to transition between the two hyperfine levels of the ground state of cesium-133 atom. This definition was given in 1967. That period is what number of duration for this number of transitions. At your level, I have to give some discussion about what is the meaning of transition. Generally, what happens in atoms, whenever an electron gets some energy from outside, it will jump to the higher level of the higher energy level of the atom and stays there for a very less time, very small interval of time, and comes back to the lower level, and this is known as transition. And that is the number of transition, this much transitions. If the number of transition happens to be this value in CGS-133 atom, then the interval of time is 1 second. You have to just remember it. Then the definition of ampere. The ampere is that constant current which, if we maintain in two straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 into 10 raised to power minus 7 Newton per meter of length. This definition was given in 1948, but I have just read out this paragraph. Let us understand what is ampere. Suppose we take two wires and the two wires are parallel to each other and a current is flowing in this wire. Let the current is I1. If current I1 is flowing in this wire, definitely near this wire there is a magnetic field, and if in this magnetic field suppose a second wire is placed and same current is flowing in this wire also, now there is a current carrying conductor placed near inside a magnetic field. Definitely these two wires attract each other, because as you know in class 10th, whenever a current carrying conductor is placed in magnetic field, it experiences a force, and we have discussed about Fleming's left hand rule to find the direction of force. So I'm not going in that much detail, but if first wire is kept there and current I1 is flowing in the wire, or suppose current I is flowing in the wire and parallelly a second wire is placed and same amount of current is flowing in this wire also, definitely these two wires interact. If they are 1 meter apart, if these two wires are 1 meter apart and kept in vacuum, then and force between these two is 2 into 10 raised to power minus 7 Newton per meter. That means force per unit length is 2 into 10 raised to power minus 7 Newton. Then the values of currents flowing in these two wires are 1 ampere each. This is actual definition, and you will learn about this concept in class 12th. So this is about ampere. Then similarly, now this ampere will now be set by the elementary electric charge E, which is given as 1.602176634 into 10 raised to power minus 19 coulomb. In fact, when expressed in coulomb. In 2019, like as there is a change of definition of mass, there is a change in definition of ampere also, and it is now uh, given in the terms of charge on electron. In class 10th, we have discussed about number of electrons present in 1 coulomb of charge. And by the basic definition of electric current, it is I equals to Q divided by T. And if it is I equals to Q divided by T, then in terms of charge and time, we may define electric current. How can we define? Suppose if 1 coulomb of charge is flowing through a wire in 1 second, current is 1 ampere. And for charge to be 1 coulomb, 6.25 into 10 raised to power 18 electrons should pass through the cross section. So in terms of electric charge, it may be defined as when 6.25 into 10 raised to power 18 electrons crossing a cross section of wire in 1 second, then current flowing in the wire is 1 ampere. Kelvin, this is unit of temperature, and it is defined as the fraction 1 upon 273.16 of the thermodynamic temperature of the triple point of water. Now, what is triple point of water? It is again a new term to all of you. This is temperature at 1 atmospheric pressure when the three states of water coexist. That means it is a solid state, liquid state, as well as in gaseous state at 1 atmospheric pressure. Then that temperature is if it is divided by 273.16, we get 1 Kelvin. It is also known as absolute temperature. And there are some other units of temperature, degree centigrade and all, Fahrenheit, degree centigrade. These are also the units of temperature, but SI unit is Kelvin. The Kelvin is defined by taking the fixed numerical value of the Boltzmann constant K to be this when expressed in the unit joule per kilogram. That value is what? 1.380,649 into 10 raised to power minus 23. This is value of Boltzmann constant, and definitely this definition is also changed in 2019 only, and it is now defined in terms of Boltzmann constant. And you must have observed till now that why there is a change in defining units, because the previous units are defined and they are related to some physical material, and now these definitions are free from physical material. That means a physical material may behave differently with passage of time or in different situations. To avoid these changes, the constants are involved in defining units. Then candela, this is intensity of light. The candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 raised to power 12 Hz, and that has a radiant intensity in the direction of 1 upon 683 watt per steradian. This is about the measurement of light. Generally, the measurement of light is studied in photometry. एंड ल्यूमिनस इंटेंसिटी मीन्स आप इसको ऐसे समझ सकते हैं कि अगर कोई बल्ब ग्लो कर रहा है तो उसका ग्लो का जो मेज़रमेंट है दैट इज़ ल्यूमिनस इंटेंसिटी, और ल्यूमिनस इंटेंसिटी को मेज़र करने की यूनिट है कैंडेला. तो यू मे रिमेंबर दिस डेफिनेशन. आई एम नॉट गोइंग इन सो मच डिटेल बिकॉज at this stage it is quite difficult to understood, or I just say first of all remember this unit, and later on we will discuss about and we will relate in next or coming lectures these quantities. The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. This definition was given in 1971 and it is also changed. And it is the mole is defined in terms of Avogadro's number. The plane angle d theta is the ratio of arc ds to the radius r. Its SI unit is radian. Suppose This is plane angle. Arc is, this one is arc, and these two are the radius, and this arc must subtend some angle. This angle is plane angle. You can also define in this way. This is a ray and it is rotated by some amount. So you can say the amount of rotation of any ray about a fixed point is known as plane angle, and this is a phenomena in 2 dimension. And as we know, if this arc may be part of a circle, and if we form complete circle, the complete arc will subtend an angle 360 degree at the center of circle. Then arc upon radius is angle, ds upon r, where ds is arc, r is radius. Now probably the last topic, solid angle. Now suppose the area DA is there. This area DA, it subtends an angle at this point. Then the distance of area from the point is, suppose it is R, then the solid angle may be defined as, solid angle d omega is the ratio of the intercepted area dA of the spherical surface described at the apex O. This is apex, जो इसका pointed point है इसको apex कहेंगे. O as the center to the square of its radius, and its SI unit is steradian. Then the formula is dA upon r square. You may compare, the previous one is ds upon r square, length upon radius, it is area upon r square, and the unit is steradian. Now there are some important point about writing of units. Very first, even if a unit is named after a person, the unit is not written in capital letters. That is, we write joules, not capital JA, JOULES. If it is started with capital J, it signifies a name, but if it is a unit, it should start with small letter. For a unit named after a person, the symbol is a capital letter. For example, joule, we write J and the rest of them are in lowercase letters. For example, second in S. The symbols of unit do not have plural form, that is 70 meter, not 70 meters, no M and S. Or 10 Newton, no 10 newtons, no plural form is there. Punctuation marks are not written after the unit. For example, 1 liter 1000 cc, there is no any punctuation. Dot dot नहीं लगाएंगे कि cubic centimeter है तो इसका short form है, not needed. 10 cc means 1000 cc means 1000 cubic centimeter. Some units are retained for general use, though outside SI units. These are the basic units which are generally we use, but these units are not the SI units. And this is a list. There may be some other units generally which we use in physics, but they are not the part of the SI system of units. So many CGS units, they are not the part of SI system, but they are still used. This is all about the lecture. I hope you can understand well, and if you have any doubt, you can ask me on my WhatsApp number or in Google Classroom. Thank you.